General, hello. My name is Alex Garcia. I am the creator of sqlite-vec. It is a vector search SQLite extension, so you could do vector search related tasks uh, and other things within SQLite. It is a very low dependency tool. It's open source, dual license MIT and Apache 2. SQLite-vec is part of the Mozilla Builders program, which I'm very excited about. They offer a lot of support, like this Discord channel, and a few other things that really make this project alive and will ensure that it will last for a very long time, which I'm very excited about. Today, a few days ago, I released version 0.1. This is the first stable release of sqlite-vec. There will be many more changes in the upcoming future, whether it's new features or or other things, but this is the first stable release. So you are able to install SQLite-vec in a variety of environments with a variety of programming languages and other language bindings that are out there. So feel free to try it out in your projects. I'll do a quick demo of how it works and kind of like the ideas behind vector search and what makes SQLite-vec unique compared to some of the other vector search tools that are out there. And we'll go on from there. So, we'll do quick demos in a few different programming languages. If we have time, we'll do talk about a few other things about like cool tasks that you could do with embeddings, such as building classifiers and other stuff. And then at the end, we'll do some more, Q&A if you have any questions about SQLite-vec itself, any future features that we may include, and just talk a little bit more about like vector search and other open source AI tools that are out there. So again, feel free to drop your questions in the chat. I will keep an eye on how that goes, and we should be good. Do a quick water take. One sec. All right, so in this demo, I am working in a Jupyter notebook in Python. SQLite-vec is a SQLite extension that works in many other programming languages. It doesn't just have to be in Python. However, Jupyter notebooks are kind of nice because I could like run pieces of code and see output right away, which is very good for this demonstration. But just know that you could use SQLite-vec in Node.js, Ruby, uh, Rust, C, Go in the browser with WebAssembly. There are many different ways to use SQLite-vec, but in this case, we're going to be using a small little Python notebook. All right. So the idea behind vector search is that you can generate embeddings of your data, whether it's text, videos, pictures, audio, and it gives you a new way to explore that data or a new way to find similar data compared to certain searches. So essentially, what we'll do in this demo is like a end-to-end, like what vector search is good for, what SQLite-vec is good for, and in this case, we're going to be working on a small data set that I scraped called stories.json. All right. So this is a JSON file with an array of objects where every object has a headline and a URL. This data comes from NBC News. I just scraped some website or some site, a page on their website that I found of like recent headlines. So these are headlines in the past 7 days. I believe there's around 500 elements or so inside of this data set. So what we're going to do is we're going to generate text embeddings from the headline field within this data set and create a semantic search engine. So what we'll be able to do is we'll be able to look up more general terms like climate change or sports or politics, and ideally we're going to get results back of news articles that are related to that. So the political articles or the um, political articles or sports related articles or things of that nature. So that's what we're going to do in this demo in Python with this Jupyter notebook. All right. So what we're going to do, so in this Jupyter notebook, there's only a single dependency that isn't the standard library, and this is this SQLite-vec package, which you could install with pip install SQLite-vec as you if you want to do it at home. Everything else would be a part of the standard library, so we're not using requests, we're not using HTTPX, we're not using any of that. It's all going to be in standard library Python except for this one package. Now, SQLite-vec just stores vectors. It just stores embeddings. It doesn't generate embeddings for you. To generate embeddings, you're going to want an embeddings model, so an AI model that will, given text, it will output a fixed size vector. There's many different ways to do this. There's PyTorch, there's sentence transformers, there's third-party APIs like OpenAI and Nomic and Cohere, and a bunch of different ways to generate embeddings, right? In this case, since we are in the Mozilla AI Discord, we're going to be using LlamaFile, which I have a link to down here. So what LlamaFile is, let me switch to my Chromebook. So Llama is an easy way to run large language models on the command line, and it gives also a nice little UI to do so. But one smaller feature of Llama is that you can run embeddings models with Llama, and it gives you a server that you can send HTTP requests to. Now, one nice thing about embeddings models is that they're much, much smaller than large language models. If you're familiar with open source large language models like Llama 3 or Gemini or some of those other ones, they're very large. They could be like dozens of gigabytes or even larger. And that requires a lot of resources to run, a lot of memory, probably GPU if you want to make it go a little bit faster. But embeddings models are typically much smaller. The state of the art ones might be in the low gigabytes, like 1 or 2 gigabytes. But a lot of the really good ones that are good enough, especially for these use cases, are much smaller. So in this case, we're going to be using Llama, and we will be using this embeddings model from sentence transformers called all mini LM L6v2. This is a very small embeddings model. It came out a few years ago, so it's not as advanced as some of the other ones. But it's around like I think on my disk, it's in the dozens of megabytes, like 500 or 100 megabytes. It is quite small, very easy to run, and that's what we're going to be using for this demonstration. So what I have running in the background behind this Jupyter notebook in my terminal, I already have Llama installed. So let me make my screen a tad bit bigger so you all can see. So I have Llama installed. It is a single file that works on all operating systems, which is a very nice trick that Justine and some other people were able to figure out. But I have the program. I have this model downloaded in gguf format, which if you look at in the Google Doc, if you follow that link, there's a tutorial on how to download Llama and how to download this exact model. So that's what we're going to do. And if folks are coming in into the chat and you only hear music, try leaving and rejoining again. You should be able to get it in. You're probably in the waiting room, which is like the not into the event yet. Just make sure to leave and rejoin, and you should be able to hear me after that. So I'm going to launch Llama. It's going to be running in the background. And what I have here in Python, let me zoom out a little bit. In Python land, I have a small little function here that we can use to interact with Llama. So given text, get an embeddings back a vector that is 384 dimensions or 384 elements long. So we have this function embed. It will hit localhost this localhost URL, which is what I have running in the background right here. We will post a JSON object with the contents of what we care about. In this case, it will be the headlines that I showed before from stories.json. So we're going to post these individual headlines to the server. We're going to get back a JSON response. We're going to parse out the embeddings, the embedding field within that, and we'll have our embeddings. So in this case, if I wanted to embed text like Abraham Lincoln, this function will return a list of floats, and this list of floats will be 384 dimensions long. And I'll clear this out so it doesn't take up too much space. But that's the general gist. So we have a function embed. Given text, we will return an embedding representation of that text based off of the embeddings model that we're using. And again, this is Llama that's generating these embeddings that's running in the background. So to use SQLite-vec, we're going to use the built-in SQLite 3 Python library that already exists within all Python versions. We're going to use the SQLite-vec SQLite-vec Python library to load in the SQLite-vec SQL functions into the connection. So it's just SQLite-vec.load. And we're going to create a schema to host this data set that we have here. So remember, this is the data set, one story. Every object has a headline and URL. So what we're going to do is we're going to create a table called articles, where we store an ID, the headline itself, and the URL. And we're going to have a separate virtual table using SQLite-vec called vec articles. And we're using the vec0 virtual table module. So this is a specific function that's part of SQLite-vec. It is very similar to full text search. So if you ever used SQLite's full text search extension before, it's a very similar setup. So in this case, we're going to create a virtual table, so slightly different syntax that we have above. We're going to call this vec_articles. This is a convention. You don't have to call it vec_, but I like it how it matches with the source table articles. We're going to use the vec0 module. We're going to make sure that we're going to declare a primary key, and this is going to be the same ID. This article ID will be the same ID that we have up here. And we're going to create a vector column called headline embeddings. So again, our embeddings generator, the one that we're using, the all mini L6, LV2, whatever, that embeddings model outputs vectors that are 384 elements long. So there's 384 floating point elements. So that's how we're going to declare the vector column here. It is a float vector with 384 elements, and it's an embeddings representation of the headline column. So this is the schema that we have. Both of these tables are completely empty, and we're going to fill them in with data right now. All right. So what we're going to do is we're going to load in the stories.json into a Python variable like so. So we're going to read in the file, parse it as JSON. And this is an example of what that looks like, matches the same exact file that we have here. So it's a JSON array with a headline and URL key inside of every object in that array. All right. I'm going to clear this so we can see a little bit better. So the way that we're going to load it, the way that we're going to insert this data into SQLite-vec or into our SQLite database is we will create a transaction, this with DB thing right here. This is a way in the Python SQLite library to create a transaction. So as soon as we start this, it will begin a transaction, and at the very end, it will commit it. This is for data integrity and performance reasons, to be quite honest. This makes it a little bit faster than some other methods. So what we'll do is we'll start that transaction. We're going to do a for loop over every single story within that story's list. We are going to embed the headline. So here we get the headline value inside of that object. We embed it, and this is going to be a list of elements that are 384 dimensions long. We are going to insert. We're going to insert into the source table that we had. So with the ID, headline, and URL, so no vectors at all. And then we're going to insert into the vector table that we have with the same ID that we inserted into the regular table with the vector column that we have here, serializing it as JSON. So this is moving into. Sorry, forgot to run this. Let me go back there. Clear this. So now we have inserted. It's first off, it is generating text embeddings for all these elements. Again, we had 500 stories, so in this for loop that finished in 3 seconds, we were able to embed 500 headlines, which is pretty fast compared to some other models. And then we were able to save those into tables within our SQLite database that we can view like so. So in this case, if I wanted to take a look at what the articles table looks like, so doing a select all from articles, just the first 10 records, we can see it returns the ID, the headline, and URL. And if we wanted to take a look at the vector table that also stores it, but just the vectors, we can see that it has the same ID. So it still has the same ID 0, 1, 2 as before, but also has a compact representation of the vector that we inserted. So the 384 dimensional floating point vectors that we generated from up here and inserted, we could see that it exists inside of this vec articles table. So that's cool. So we have our data loaded into SQLite. That's great. And we also generated embeddings of those headlines and also sorted them into SQLite inside of this vec articles virtual table. And now the most common thing that people build with vector search is a semantic search engine, right? So what we're going to do is with those vectors that we have, all those embeddings, we are going to do a KNN style query. Let me clear this out so we can see a little bit better. So we're going to do a KNN style query, meaning that we have a search term that we have, right? So in this case, I want to see all the stories about the stock market from these, recent headlines. So what we're going to do is we're going to embed this text query that we have to get a floating point, 384 dimensional floating point vector of that query term that we had. And we're going to take that embedding and we're going to find the closest one compared to all the other 500 articles in the data set that we have to see what articles have to do with the term that the query that we have. So that way, we'll get articles about the stock market crash that happened yesterday, or a few other like economic related news articles. So this is a vector search. We have our term, we embed it, and then we perform a query directly on the tables that we have using just pure SQL. And to step through what this SQL looks like real quick. So here we are querying the vector table that we declared before that contains all the embeddings that we have. We are doing a match on headline embeddings. So remember, headline embeddings contain the embeddings representation of the headlines of the data set that we have of each individual news article headline. So we are doing a match on that, and we only want the k nearest item. So in this case, we only want 10 of the nearest headlines that have to do with the query term that we have. So again, we have a query, we embed it, and we're getting the 10 closest items to that query. again, using all SQL. And we can see when we run it, we could see like, oh, they have the worst day since 1987, or stock market live updates, sell-off continues as investors do whatever, or markets are clamoring. Again, all of these results that are returned about recession and certain stocks that are plunging have to do with stock market, because that is the query that we had. We embedded it into a vector in the same vector space as the database as what we had before, and we get results, the 10 most related results to that. One thing to note is that our query term had stock market, but not all of these results have the word stock market in it. For example, like here, recession fears, traders repositioning, spark market sell-off. It doesn't say stock. It does say markets, but it doesn't say stock market. Or Intel shares plunge. It's still able to figure out, like, the nice thing about embeddings models is that it's not an exact search, right? It's more fuzzy, semantic, like meanings of relationships between words, not necessarily those exact words. If you did want full text search, like, I want stock market, I want to see the exact term stock market, that already exists in SQLite as the full text search extension. If you look up SQLite FTS5, there's an entire documentation page about that. But with vector search, you get kind of like a fuzzy semantic search around it. So for example, if I change this query to sports, and I'll get results about the Olympics and Olympics recap and things of that nature. Or if I looked up something about like White House, the results I get, some of them do have to do with White House. Others of them are about the current election that's happening. These headlines don't specifically say White House or presidency, but it could still like kind of suss out the meaning based off of the embeddings model that we used. So again, we had a data set, we generated text embeddings with that, and after we did that and stored them inside of a SQLite-vec virtual table, we were able to do k-and-n style searches right on top of that. So this is in Python. So if I wanted to, I could save this database into a file. So, a newsarticles.db file, and I could share that with other people, and they could load it into whatever environment they like, right? So if I had a coworker who was also using Python and also had a Jupyter notebook, I could send the SQLite file over to them. And as long as they had the same embeddings model or Llama file running in the background, they could do the same exact thing. They could do a k-and-n style search. If my coworker was using Node.js or JavaScript, they could do the same thing. It's still the same SQL under the hood. It's still the same embeddings models, but they could do it in different environments as well. Or the browser with WebAssembly, or in Go, or Rust, or C. All the different ways you could use SQLite-vec and other programming languages all boil down to the same SQL and the same statements that are run. As an example of that, I have another notebook here. This is another Jupyter notebook. This is running Dino, so it's another JavaScript runtime that's similar to Node. The only reason why I'm using Dino in this example is because they have good support for Jupyter notebooks. It just comes right out of the box, so I can run this notebook as I wish within this VS Code environment. So in this case, like Node.js, completely different environment, but I can do the same steps that I did in the Python notebook to generate the same data set, right? So in this case, if you remember before, at the very top, we had this embed function that took in a string and then used Llama file, sent it an HTTP request, got JSON back, and we were able to generate embeddings like that. We could do the same thing in JavaScript using the built-in fetch method. So we could fetch directly from Llama file, parse out the exact data that we want. We can use a different SQLite client library because Dino is different. They have their own like SQLite client library, just like all other programming languages, and JavaScript has many different SQLite client libraries. But we can do the same thing. We can create a database. We can load SQLite-vec inside of it. We can create the same schemas, create the same table. This is the exact same SQL that we're using in Python. It is just a slightly different API because we're using JavaScript. We can insert. We can go through the same stories.json file that we have, loop through all the entries, generate embeddings from that, and then within that database, we can run the same exact insert into statements to insert data into the database, and insert vectors into there as well. And then at the very end, we can do the same k-and-n style search, right? So this is a k-and-n style search to get given a query like global warming. We can embed it, do a k-and-n style search using the same exact SQL, and we get very similar results. We get the same results, actually. Different programming language, different runtime, But at the end of the day, same embeddings model, same SQLite database, and same results that we get with semantic search from JavaScript compared to Python. We could also do this in pure SQLite. So one project that that coincides with SQLite. So SQLite-vec is one vector search SQLite extension, right? And it just has to do with vectors. So storing vectors, querying vectors. That's all that SQLite-vec does. It doesn't generate embeddings. It doesn't do model inference. So I have a separate SQLite extension if you just wanted to stay in pure SQL space. I have a separate SQLite extension called sqlite-rembed. I'll actually share my screen for this one. So inside of this document, I have a link to sqlite-rembed. Oh, typo there. Fix that. So SQLite-rembed is a separate SQLite extension. It is not required to use SQLite-rembed with SQLite-vec. As we saw in the previous example, we did embeddings model inference in Python using Llama file, using an HTTP request. In Node.js, we did a similar thing. This is another option that you have to generate text embeddings from your data. This is another SQLite extension, so it's very, very similar to SQLite-vec. You download it, you load in the model. In this case, one sec. In this case, things from remote APIs, right? So if you think of, I'll show you some of the supported ones. So OpenAI, Nomic, Cohere, these are all embeddings. Embedding services. So they have, you probably pay them a certain amount of money to send HTTP requests to their APIs, and it will generate, and they'll generate, given text, it will generate embeddings for you. So it'll generate vectors. So to simplify all this, so to simplify like hitting all these different APIs where they have like slightly different input requirements or slightly different outputs. Maybe their JSON has an extra key or something like that. SQLite-rembed kind of standardizes all those requests. So SQLite-rembed using pure SQL, you can configure it to say like, hey, I'm using OpenAI, so hit OpenAI servers, use this API key, and return results back. And these are from remote sources. So in OpenAI's case, it's hitting api.openai.com. Or in Nomic's case, which is another embeddings provider, it's hitting nomic.ai servers. So SQLite-rembed is a way to hit remote API endpoints to generate embeddings given text. In this case, if we wanted to use the same in this what we were working on before with news articles, we can use SQLite-rembed. So in this case, this is a Jupyter notebook that's running a Bash kernel. So this is just running all pure Bash, no Python or Node.js or anything. So in this case, I'm running an install script to install SQLite-vec and SQLite-rembed. This will download. I could show you on the sidebar here. This will download these two compiled extensions, vec0.dylib and rembed.dylib. These are compiled SQLite extensions that are for my specific computer. So I'm running on a Mac M1 Mini. So Mac OS uses .dylib as their share object file naming convention. So this install script that I have that's available for SQLite-vec and most of my other SQLite extensions, it downloaded the exact compiled extension that I needed for my computer. So I downloaded those. I'll clear this out so we can see. So the extensions themselves are downloaded, and I can use just the pure SQLite 3 command line interface called SQLite 3. This is available in most operating systems. Linux has it pre-installed most of the time. Mac OS has it installed most of the time. Windows, you can install it very easily as well. It is very small. It is written in PRC, so it's like 600 kilobytes or something. But what I can do is I'm going to use SQLite-rembed to hit the same Llama file that I have running in the background. So this, Llama file server that's been running in my terminal in the background, I'm going to use that Llama file server with SQLite-rembed. This is how you configure it to generate text embeddings. And what we'll do is, just like before, we have a create table statement. We could insert it directly in it. We could insert data from this stories.json file. Here we're reading in that file, that JSON file. We're using SQLite's built-in JSON extraction functions. In this case, we're going through every single object inside of that array, and we're inserting that data directly into the articles table. But when we want to generate text embeddings, we can use the rembed function right here. So rembed, the first argument for this rembed function is the name of the client that we have configured. So the client that we configured up here, we used this client. This rembed client has a name llama file, and we're pointing it to the default llama file settings. So in this case, localhost port 8080, and we are generating a embeddings using llama file of the headline inside of every single headline inside of this data set. So headline is text. We're converting it into a vector of 384 dimensions, and we're storing it inside of this vec articles table. Again, this is in pure SQL, pure SQLite. The only dependencies that we have, we installed up here, the two precompiled extensions, vec0.dylib and rembed.dylib. We install them up here. We are running straight SQL using the command line interface. Again, this is a bash notebook, so it looks a little bit awkward. The syntax highlighting isn't all there, but we were able to generate those embeddings and save them into a file called cli.db. So this is a command line interface example. .db is a database. This is a SQLite database, and it's stored both the article's metadata, the headline and URL, and the embeddings in a virtual table, in a vector virtual table. And if we wanted to do a KNN style search, we could again do something very similar. So in this case, let me run this above so that way. Oh, it's already ran before. So in this case, we are using cli.db. That is the saved file where we have all of our data in vectors. We are running pure SQL again. We are loading in the sqlite-vec. We are loading in rembed. We are configuring rembed to use llama file as the embeddings generator instead of OpenAI or Nomic or Cohere or anything. And then we perform a KNN style search. So again, this is the same exact SQL that we had in the Python version and the Node.js version, but now it is in a pure SQL version using the SQLite 3 CLI. And if we run it, we can see we get very similar results. So in this case, the query that I had is LeBron James, and we get, stories about NBA and about Team USA on the Olympics and Snoop Dogg traveling with the U.S. men's basketball team. Again, none of these say LeBron James, but they can still infer that this is going to be about basketball or NBA or Olympics. And just another example of, again, pure SQLite, pure using vector search, pure SQL, KNN style search, same exact SQL as we had in Python, as we had in Node.js, and as we have now here using pure SQL in SQLite. So let me go over to the document real quick to point out some of these links. Again, sqlite-vec, here's a link to the repository if you want to go give that a star. If you're interested more about learning about what embeddings are and what these embeddings models do, or what you can do with embeddings, these links are also here as well. Specifically, Simon Wilson's video, Tech Talk about embeddings from about like 7 months ago is a very good watch. It's around like, it's a little bit longer, but it goes into detail about what you can do with them and different tasks and features that vector search and vector databases give you. There's also the What Are Embeddings online book by Vicky Boykis that goes into the more technical details of like what these embeddings models do and kind of the architectures behind the machine learning models that generate these embeddings. One question about these demo notebooks. I will put them up into the SQLite-vec repository right after this. So if you keep an eye out on the SQLite-vec channel within Discord in the Mozilla AI server, I'll be sure to upload these notebooks onto there if you want to take a look. Also, if you go into the SQLite-vec repository, I'll do that real quick. There is an examples directory, and here I have specifically for different programming languages, a very simple like base example for how you use SQLite-vec in all these different places. So for example, if you wanted to use this in Ruby, right, there is under the examples directory, under simple Ruby, there is a directory that has a bare minimum how you run SQLite-vec using the provided official bindings. So in this case, for Ruby, there's a gem called sqlite-vec that you could just install. And using the SQLite 3 gem, here's how you load in a database, load in SQLite-vec into it. You can call SQLite-vec functions like this, how you create a virtual table, how you serialize lists into vectors that SQLite-vec expects, and how you perform a KNN style search. So that's for Ruby. Under the examples directory, there are many more like Go, Rust, WebAssembly, if you wanted to do it in the web browser, which is always fun. So again, like loading in sqlite-vec, calling sqlite-vec functions, serializing vectors, doing a KNN style search like this. For all the official bindings, whether that's Dino, Go, Rust, WebAssembly, there are simple examples for that in all those cases. And for these specific notebooks I just shared with the NBC News headlines, I will also I'll add a subdirectory into this folder with these notebooks if you want to try it out yourself. One last thing that I want to show. So there are many different things you could do with vector search and with embeddings in general. Most of the time when people talk about it for like AI applications, it typically has to do with RAG, like retrieval augmented generation, where you have a large language model and a private data set, and that large language model doesn't know about the private data set. Maybe it's like the Q&A or the frequently asked questions for like your company's wiki or something like that. So retrieval augmented generation allows you to selectively get elements within a private data set and feed it into a large language model at prompt time. So that way it has knowledge about whatever private data that you have. And one way you could do that retrieval is with vector search. It's kind of like a fuzzier search. So that's like, the typical use case around vector search and with regards to AI applications. As well as semantic search, as we showed, it's like a fancier full text search, but it's a little bit more fuzzier, and you can kind of get more semantic meaning out of it. But another use case for vector search that I really like is let me switch back my screen. Another use case of vector search for me is building classifiers. So here I have let me go back to my apologies. So one example of a classic classifier data set is this AG News classification data set that exists in Kaggle. And what this is very similar to what we were working with before. It is news article headlines. So here, like, fears of TN pension after talks about, whatever. Or the race is on. Second private team sets launch date for human spaceflight. These are all headlines of news articles from the past, and they're all classified into one of four categories. So in this case, we have one is world news, two is sports news, three is business, four is science and technology. So this is a classic machine learning project that, like, you might have done in at university or some other or somewhere else, where given these titles you want to classify one, two, three, or four to predict what kind of news article it is. So in this case, in Kaggle, what they have is 120,000 news articles that are the training data set, and then, like, 20,000 testing news articles that are pre-labeled. So you can see, like, okay, I predicted that this news article was about sports, and and it might have been about news, so that might have been wrong, or maybe you were correct, and maybe you're and your prediction model works well. So one thing you could do instead of these complicated, like, types of machine learning models that you can create and train yourself. One option that you have for something like this is by using embeddings. So what you can do is, with the training data set, you embed all the news article headlines into vectors. And then when you're given a new title and you want to predict what category to place that news article, you can embed that news article. You can compare it to the training data set to get, like, the top 100 closest headlines to that new embedding. And you could see with those 100 closest embeddings, see which categories they were given, and just take the the most commonly occurring one. So, for example, if you got the 100 closest news article headlines, and 60 of them were about science, and, like, 10 of them were about business, and 5 of them were about world or whatever, you can probably assume that those 60 business use cases are probably going to be it, right? So it's kind of like a cheaper, more off the cuff version of building a classifier data set. Instead of, like, instead of training your own machine learning model, you could just use embeddings and get, like, the top 100 closest ones and see if you're correct. So I did an example of that within this notebook right here. So Slightly more advanced Python example that we had before. It uses a few more dependencies like pandas and HTTPX, but we're still using the same Llama file server and the same embeddings model, the all mini LM L6 version 2. We're still using that same embeddings model, still using SQLite-vec, but in this case, it's for a specific task of classification instead of semantic search. So here we are running pandas to read and train.csv. This is a CSV file with three columns: class, which is the category 1, 2, 3, or 4, business, world, science, or sports. The title, which is the headline of the article, and the description. Here we only really worry about title just to make it a little bit easier. But just a speed run of what this looks like. So we create a SQLite database. We dump all of the training items into a table called train. We create a new virtual table called vectrain that is an embeddings representation of the title column as a floating point list with 384 dimensions, because we're using that same model as before. In this case, I have two separate functions for embedding. One is async, one is not. This is just to kind of make some of the batch queries a little bit faster, which is why there's an async version, which is prefixed with a, so a embed, versus embed, which is completely synchronous. This function right here, actually, I'll just run it right now because this is only, we'll do a live demo, see how that goes. So again, reading in the training CSV, creating a SQLite database out of that. We have these embedding functions that uses Llama file to embed text using the same model that we had before. And here, what we're going to do is we're going to go through what this code does is that we have 1,000 training news article headlines that we're going to go through. So we're going to get 4 of them, send them over to Llama file, save those embeddings that we generated into the vector table, and we're going to continue with the next 4. So we're doing batches of 4 over and over again. We're doing batches of 4 just to give Llama file a little bit more space to breathe, so we're not sending hundreds of requests at a time. And it happens very quickly. So again, this happens in a few seconds. This is just a log of the vectors that they were processing, so ID and headline. And now at the end of this, we have 2 tables, train and vectrain, where vectrain contains vectors of the embeddings representation of the headlines of the news articles that we care about. And once we have all that, we can have this classify function, which again looks very similar. Here, this is where we do the KNN style search. So on the vector table, we're doing a match on the title embeddings column, where this query is a embeddings of a new article that we want to classify. So if this is a news article and we want to predict what it is, we have the title, so we pass in the embedded version of that inside of here and do a match on the other title embeddings that we have. Here we're going to get the top 100 closest items and then compare the results of those. And once we have those KNN style once we have that KNN style search, we're going to use SQL a little bit to we're going to join in data on other. We're going to join in the original table that we had, which contains the category, so 1, 2, 3, and 4 of those 100 closest matches, and we're going to group them. We're going to group by that and get like a percentage of which are the most common classes, right? So we could have 60% of the top 100 closest ones are business related, or 10% are science related. Just to kind of give a more human readable version of what that looks like. And we could try that out here. Oh, whoops. Define classify. So again, right here, we're trying to classify this article that I grabbed from today's headlines about how polling hasn't, polling shows that most Americans haven't heard of Kamala Harris's newest VP pick. And if we classify that using what we had before, so we get the 100 closest vectors, we get the categories of those 100 closest vectors, and then just do a count of those, we can see that most of them have to do with world, right? These are kind of broad categories, so it's a little bit hard, but world, this is more politics related compared to the other ones, probably because it says polling in Americans. That's probably why world is the most common one here. Here's another one for Simone Biles, says she definitely sees herself as a mom someday. If we try to predict the class for this one, it doesn't work as well. We can see that this is about science and technology. That is the top one at 40%, compared to sports, which is what it should be at 23%. I think this is because this embeddings model is a little bit older. This is from a few years ago, maybe a little bit longer. I don't know I don't know about the training data set that was used to generate this embeddings model, but I imagine that maybe it doesn't have Simone Biles. Maybe that training data set didn't have enough data about Simone Biles and her as a gymnast and her as a giant sports figure, and that's the reason why I think science and technology kind of beats out the other ones here. It could also be the training data set that we have. The training data set, this classification thing from Kaggle, is from probably it's probably like 10 years old, like before Simone Biles did her first competition or her first national competition or first Olympics. Before her first Olympics, so that's probably why it doesn't know about Simone Biles as much. So there's like kind of there's some caveats there about this method, right? It really depends on the embeddings model you use and the training data set of that embeddings model, and the training data set that you're using to build the classifier. That matters as well with whatever you're trying to predict on top of that. And finally, as the last example, Bangladesh protesters call a Nobel laureate. This is classified as world, probably because of the country name and probably because of Nobel laureate. That's why I imagine world is chosen as the top response, with 64% of the 100 closest vectors being related to that. And this is just a quick, just to show what it looks like. I got the with the test data set. So these are items that don't appear in the training data set. I got the 100 closest ones. I did a prediction of like, okay, predict these 100 headlines and compare what the actual was compared to the predicted one. And at the end of it, I got like an 80% accuracy. So 80% of the articles in the training of the test data set had an accurate prediction using this embeddings approach, which is honestly pretty good. Most of the Kaggle notebooks that I saw were around in that range, mostly because this news article data set isn't the best. It's a little bit weird, as you saw with Simone Biles and with some other ones. So I think 80% is pretty good, especially because we didn't have to train a machine learning model or do some of those other crazy stuff with it. We just simply generated text embeddings for it, stored it in SQLite, did KNN style searches, and then we were good to go. So I think this is a pretty good use case for embeddings as well, like classification models. And don't be surprised if a future version of SQLite-vec has a better like first class support for these classification tasks. So that was the bulk of the demonstrations that I wanted to show. I'm happy to go through some more code samples if anyone's interested in any of the different language bindings or anything else. Happy to talk about new features as well. I see a few questions in the chat that I will answer. First off, sorry, I cannot see your name, but someone shared that they are working on getting SQLite-vec working in Dart and Flutter. That is an extremely welcome addition. Currently, the current language bindings that exist, like Python, Node.js, and all that, they're all like for the server or running on your computer, right? Like you're running a Ruby script on your laptop, or you're running a Python web app. SQLite-vec works great in those. All the bindings are great. It's just like a pip install away. If anyone out there wants to use SQLite-vec in more embedded or in smaller mobile devices, using Flutter or Android or iOS or anything like that, please talk to me, especially if you know like a lot about like Android development or iOS development. I want to have first class bindings for Android, for iOS, for React Native, and all these other all these other places, because SQLite-vec works in it. That's a unique thing about like this vector search tool compared to some of the other ones. It doesn't require a server. It runs in SQLite. SQLite runs everywhere. So if you do know about like how to package a SQLite extension or package these things into a Flutter package or Dart or however that kind of stuff works, I don't really know too much about like package management for like Android and iOS. Please hit me up either in the SQLite-vec Discord channel or open an issue up on the GitHub repository, because I'd love to get like better support for that. And thank you for sharing this. This is the same one that I saw before. It was very cool to see. Rodi or Roddy's, excuse me if I mispronounce your name, but yeah, this is a very cool repository that I will be taking a look at a lot. So thank you for sharing. Really appreciate it. Another question from Vishnu. So curious if you tried running benchmarks on SQLite-vec on mobile environments. I have not. I was able to run SQLite-vec on Termux on an old Android phone that I had, so I know that it works. I haven't tested like simmed acceleration or some of the other, unique things about that. I would say in general, I want sqlite-vec to work very, very well, and I expect it to work very well on mobile environments as well, in like the tens of thousands to low hundreds of thousands of vectors. Typically, that means like your vector index is like less than a gigabyte or so, and in that case, I think it would work pretty well on mobile environments. There's also binary quantization, which I didn't talk too much about, but essentially what you can do is instead of having in our case, a 384 dimensional floating point vector, which takes up a lot of space, that alone is around like almost a kilobyte of space per embedding. What you could do is instead of storing every element in a 4 byte floating point number, you could instead store it as 1 bit, so 32 times smaller. The accuracy isn't as good, and there are some other caveats to know about that. But with 32 times less space, you can query a lot more vectors, which is pretty good for mobile devices, right? So you can imagine a world where you have a Google Photos or another like photo sharing app on your phone, where all the photos are stored on your phone, and you use an embeddings model to embed those photos, store them as binary vectors or as bit vectors, and you could probably do good enough queries for tens of thousands, hundreds of thousands, maybe even low millions on your phone, which is pretty cool. You don't have to like, phone home to another API server or to another database. It just runs all locally on your phone. And binary quantization is probably going to be a very good use case for that. I plan on writing a blog post about binary quantization in sqlite-vec specifically, and some of the embedding models that are really good for that. For example, the embedding model that we use here, it's the sentence transformers all mini LM version 6, whatever. That's not that very good for binary quantization because it's a low dimensional thing. But there are new ones like Nomics, Mixed Bread, Salesforce, or Snowflake has one as well. And so I plan on writing a blog post that kind of compares all those approaches and seeing which one's best, as well as benchmarks to see like how many vectors you could really do when they're quantized to bit vectors.
Hi, Alex. I had a follow-up question to that. Can you hear me?
Yes, I can hear you.
Great. So we are actually building an open source alternative to Google Photos. So a lot of what you said is very
Oh,
relevant to what
nice.
we're doing.
Yeah.
Right. And a lot of this happens with the client. So we're building clip and we're building face recognition. So when we have to do semantic search on device. And so yeah, the follow-up question is: do you have plans to uh, create bindings for either Objective C or Swift or Java? Because mobile is primarily where we what we're interested in.
Yeah, I am not the best at like Android development and iOS development, but if people help me out with building bindings for Java or iOS or Swift or like all those whatever's good for mobile development, I want to build those and I want them to be available for people to use. So I don't have any plans for it just because like I know nothing about mobile development. But again, if people either post in the SQLite-vec Discord channel in the Mozilla AI Discord server, or if you open up an issue on GitHub, hopefully we can get enough people who have more knowledge about this space and I can figure out a way to like publish that because again I know nothing about mobile development. I don't know what package managers are available or like what the typical approaches are for that. But my goal is to get SQLite-vec running everywhere, so every mobile device, every operating system, and if I could build language bindings that make that easier, more than happy to do so. Yeah,
Got it. Thanks, Alex. We will figure out how we
yeah,
can help you out. And congrats again on the launch.
yeah. Thank you, appreciate it. I'm going to look at the chat. I see a few more. So the tool for KNN search is all in SQLite-vec. So by performing a specific SQL query on virtual tables, you could do a KNN style search. It doesn't require an outside server like Elasticsearch or Pinecone or anything like that. You can do that all in SQLite-vec using just pure SQL. Oh yes, so sqlite-vec is a part of Feast now. Thank you, Francisco, for contributing to that. That was very very cool to see. I've seen sqlite-vec in a few other smaller or in a few other Python libraries like that where they want some sort of vector search support. So they have they use sqlite-vec for a lightweight option to do that. So that's very cool to see. So thank you for sharing. What embeddings model is best for semantic search? There are so many embeddings models out there. I would say just try them and see what works best for you. I personally like the open source ones because you could run them yourself. They're not like gate walled behind some, third party server. You can run them yourself. You have many more different options in running them. There's even a lot of like software as a service companies that will run open source embeddings models for you if you can't do so, if you're like in a constrained environment. So personally, I'm using the one that I use for this demo, the All Mini LM version 6 from Sentence Transformers. That's usually my go-to because it's very small and very fast to generate embeddings for, even if it's a little bit older. And if I notice quality issues or if I need something better, then I'll level up to some other ones. Specifically Nomic and Mix Bread AI. Those two are some, more open source, easily reproducible ones that have fairly good quality, and they support some, advanced features like binary quantization, matryoshka, representational learning, a few other things. Those are usually my go-to. I would say the new Snowflake model, Snowflake 1.5, that one is very interesting to see. It has multiple sizes, so small, medium, large. It has support, I believe it has support for matryoshka and binary quantization, or at least scalar quantization, with pretty good performance. So like those are usually my go-to. And again, I'll probably have a blog post about like what ones work best with on local devices. I'll probably have a blog post dedicated to that using sqlite-vec and trying out all these other embeddings models. Also, in Mozilla AI, so folks over in Mozilla, as part of the Llama File project, there's a blog post out there. I'll probably drop it in the Google Doc when I find it. But they compared some of the open source embeddings models and which ones are very good and which ones perform a little bit better than others. That's probably like the best thing to check out if you're trying to choose which embeddings models to use. So. Okay, another question. So if you have a fixed data set for semantic search, if you fine-tune an embeddings model, would that be helpful? I'm not the best person about fine-tuning embeddings models, but I believe that to my knowledge, fine-tuning is an intense process and is a little bit hard to do correctly. I would say just like see if the results that you get are good enough, and if you need something more out of it, you could either try other embeddings models to see how they are, and your last resort would probably be, to fine-tune an embeddings model itself, because that requires training, that requires, a lot more compute, a lot more resources to do for a very specific task. So I would try other embeddings models first, see which ones work best, and see, and also like if anything, I think a better use case would, or a better thing to do first is creating an evaluation data set for the problem that you have. So for example, if you're doing like semantic search over images, if you just have a test suite of like example, real world images that people have and real world queries that people have, and you have an evaluation data set to be like, oh, this embeddings model, gets the top 10 results 80% of the time or 85% of the time. I think usually like building evals like that are better in the long run than like trying to fine tune a model. Maybe through that process, you'll see that you can go from 80 to 90% by fine tuning a model, and maybe that's worth it for you. But you don't really know until you have like hard numbers or hard evaluation test suite to kind of like back that up or to justify the expense of fine tuning. Yes, so once I do figure out Android and iOS binaries, they will also be available through GitHub releases. All these models, like all the bindings that I have, so the Python bindings, Node.js bindings, all of that, they all use the same pre-compiled extensions. They're just like provided in different places to kind of make your life a little bit easier. So if you pip install npm install on the same platform, it will be the same exact pre-compiled extension. That extension is also available on GitHub releases. So if you just want to download directly from GitHub releases from a URL just to make your life a little bit easier, you could totally do that. And I will do that for iOS and Android once those are out. So they will be both on GitHub releases as a hard URL if you just want that right away. But I also like providing these these nicer, easier to use package managers like pip or npm or gem or cargo or these other package managers just to make your life a little bit easier. Not all the time can you like reliably download something from a URL and like have it in production. If you're already using pip or cargo or these other package managers, it's typically best to like stay in that supply chain, right, and kind of like use the tools you already have for like security notifications and everything like that. So that's typically why I do like both a hard URL on GitHub releases as well as like Python and wherever else. Oh, thank you for sharing the leaderboard for the retrieval models. There are like this leaderboard is probably the best one, but there are like evaluation benchmarks that people have built for embeddings models, and that's typically what whenever there's a new embeddings model release, people will talk about like what score they get. Like, oh, I get a 65 in this benchmark, or I get a 64 in this one. So definitely take a look at those as well. But I think the best benchmark you could do is like using your own data, right? Because like you know it's a very different task to classify news headlines like we're doing here compared to like classifying medical records or classifying like photos on your phone or classifying like hate speech on social media. Embeddings Different embeddings models will do great at whatever like you're trying to do. So these leaderboards are great, these benchmarks are fantastic, but like the best benchmark would be like one that you build yourself for whatever business or personal use case that you have for these embeddings. Yes, I would say the all mini LM L6 V2 model. It's a little bit older now. It's a little bit more dated. So like some of the newer embeddings models are probably better. But like again, it's open source. It's really easy to install. It's super fast to do inference against. Using Llama file, for example, like we did 500 embeddings, generated 500 embeddings using a single thread in like 3 seconds, which is pretty good. Other models like can take a little bit longer, or if you have like if you're hitting a third party HTTP API, then you have to worry about like network requests and retries and everything like that. So that's typically why I use all mini LM L6 at least at first, and then once I learn more about the data set or how things go, then you can like use something a little bit better. So again, feel free to drop questions in the chat if you have any. And yeah, I will also drop the Google Doc with all these links in the SQLite-vec Discord channel. And again, if you have any questions, whatever, feel free to drop them in there or open up a GitHub issue or anything else.
Yeah, thanks, Alex. I just want to be conscious of your time. You've given us an hour here. We really appreciate you hosting this event, and it's been great. Lots of great information. So yeah, we could probably continue in chat just to give you a break.
Awesome. Thank you. Really appreciate it. Cool. So again, if you have any more questions, feel free to go to the SQLite-vec Discord channel. Happy to answer questions there. If you run into any bugs or have any feature requests, you can go to the SQLite-vec GitHub repository and like open up a new issue there. And again, the Google Doc with all the links to all the different data sets and everything, I will post that in the Discord channel right after this. And I will upload these notebooks that I showed inside this presentation into the SQLite-vec repository very shortly. So thank you again, and hope to see you soon. I hope you use SQLite-vec in all your projects. So